Hello everyone, I, Mrs. Komal Rahul Pardeshi, working as an assistant professor in Computer Science and Engineering Department of Walchand Institute of Technology, Solapur. Today I am going to deliver a lecture on internal representation of files in Unix operating system. The learning outcome of this lecture is, after watching this video, student will be able to describe the internal structure of files in Unix. As we know, in Unix, everything is treated as a file. Even devices are also treated as a special file. All devices are represented by files called as a special files that are located in /dev directory. Thus, device files and other files are named and accessed in the same way as a regular file. A regular file is just an ordinary data file in the disk. Devices files are categorized as a block special file and character special file. In block special file, data gets transferred in terms of blocks, so it has characteristics similar to a disk. In character special file, data gets transferred by stream of bits in sequential order like keyboard. So, character special file has characteristics similar to keyboard. In Unix, everything is treated as a file. So, Unix operating system represents file as an inode, which is also referred as index node, which contains the information necessary for a process to access the file and other information such as owner, access permissions and access times. Inode exists in static form on disk and the kernel. It reads into an in-core inode to manipulate them. So disk inode is loaded into the memory, which is called as in-core inode. So we can say that inode has two types, disk inode and in-core inode. Disk inode consists of below given fields. First, file owner identifier. As ownership of file is divided as individual owner and a group owner. Group owner means set of users who has access rights to a file. There is one more user called as a super user. Super user has access rights to all the files in the system. The next field is file type. Files may be of regular, directory, character or block special file, or it may be a FIFO, that is first in first out, which is also called as a pipes. Third field is file access permissions. The system protects files according to three classes. First, owner of the file. Second, group owner of the file. And third, other users. Each class has access rights to read, write and execute the file, which can be set individually. As directories cannot be executed, execution permission for directory gives the right to search the directory for a file name. So, when we say that there is an execute permission for a directory, it means we can search any file in that directory. The next field is file access times. File access times means when the file was last accessed, when the file was last modified. This field gives the time associated with the file. The next field is number of links to the file. Number of links to the file represents the number of names the file has in the directory hierarchy. Next field is table of contents for the disk address of data in a file. Though user treats the data in a file as a logical stream of bytes, the kernel saves the data in discontinuous disk blocks. So, the address of these disk blocks are stored in a table to access the file data, and using these disk addresses, the inode identifies the disk block which contains the file's data. The next field of the disk inode is file size. Data in a file is addressable by the number of bytes from the beginning of the file, starting from byte offset 0, and the file size is always greater than 1, the highest byte offset of the data in the file. For example, if a user creates a file and writes only 1 byte of the data at byte offset 1000, then the size of the file becomes 10001 byte. Remember that inode does not specify the path names that access the file. Here we have sample disk inode. This inode is that of a regular file created by user MJB. So, owner of the file is user MJB. Group owner of the file is operating system. Type of this file is regular file. Now, the permissions given to the file is read, write, and execute. Now, the user MJB has all these permissions set, read, write, and execute. But the group owner, that is OS, and all other users can only read or execute the file but cannot modify. Means they have only read and execute rights for this file. Now the file can be accessed on October 23, 2017 in the afternoon 1:45. The file was last modified on October 22 in the morning 10:30 am. The inode was created on 23/1984 1:30 pm. The size of the file is 6030 bytes, and the inode also contains the disk addresses. As I already told, disk addresses is nothing but the file data is scattered on logical disk. The disk block addresses are stored in a table which is referred as a disk addresses. Now, whatever we study is all about disk inode. Now pause video and write your answer for the question, when will be the content of disk inode get changed by the kernel? Okay. Now we will see when kernel changes the content of the disk inode. The kernel encodes the information in the inode. Now there is a difference between writing the content of an inode to the disk and writing the content of a file to a disk. The content of file gets changed only when we writing it, and the content of an inode change when changing the content of a file or when changing its owner permission or link setting. That means changing the content of files automatically implies a change to an inode, because changing the content of files means we are updating that files. Automatically size of that file will get changed, so inode also get changed. But changing the inode does not imply that the content of file change. Means if we change owner of the file or permission of the file, it does not mean that the content of file get changed. If we change owner or permission, then only the content of inode will get changed. Whatever we studied is all about disk inode. Now the next type of inode is in-core inode. The in-core inode is nothing but the representation of disk inode in memory. Whenever kernel wish to access any file, it copies the data from disk inode to an in-core copy of an inode. So in-core inode contains the fields along with the fields disk inode. It contains below given fields: the status of in-core inode indicating whether the inode is locked, The process is waiting for an inode to become unlocked. The in-core representation of inode differs from the disk copy as a result of change to data in the inode. The in-core representation of inode differ from the disk copy as a result of change to the file data. And the file mount point. The mount system call connects the file system in a specified section of disk to the existing file system hierarchy. This is the first field of in-core inode, that is status. The next field of an in-core inode is the logical device number of the file system that contains the file. The second field is the inode number. Since the inode are stored in a linear array on a disk, the kernel identifies the number of disk inode by its position in array. Next field is pointer to other in-core inodes. The kernel links the inode on hash queue and on free list. In the same way, it links buffer on hash queue and on buffer list. So, it must have pointer to point to other in-core inode in the list. And the last field of in-core inode is a reference count, which indicates the number of instances of the file that are active. Means how many number of files are opened by currently executing process. This is all about Unix operating system, which represents file as an inode. Now, there is assignment for the student that they have to write down the answer for the below given question. How devices are represented in Unix? What is an inode? Write and sample inode structure for any regular file you created. Thank you.